Hello students, in the previous class we started with matrix multiplication, how to multiply two matrices, what is the condition to be satisfied, and we did a few problems on finding the product of two matrices. Let me recollect a few things. If A is a matrix of order m by n, then B must be of order n by L, because the number of columns in the first matrix should be equal to number of rows in the second matrix. Then only we can find the product. Then the resultant matrix AB will be having the order m by L. Okay, and we did problems based on that. And how to multiply? We have to multiply row elements with column elements. Okay, suppose in the product, this is the first row, first column element. Then we have to multiply first row of the first matrix with first column of the second matrix. So that is the answer for the first row, first column element. Suppose if I am going to find x1, 2, this is the first element which corresponds to the first matrix and also correspond to the row number. So we have to multiply first row of the first matrix with second column of the second matrix, and the number of elements in the row, okay, this is number of elements present in this row, should be equal to number of elements present in this column. So first element will be multiplied with the first element, second element will be multiplied with the second element, and the third element will be multiplied with the third element. This is the process of finding the product of two matrices. So let us solve few problems in this product of matrices. Consider this problem. We are having two matrices. One is a row matrix which is going to have x1. So what is the order of this matrix? Order of the first matrix is 1 row, 2 column. And the second matrix, it is 1, 0, minus 2, 0. The product is going to be a null matrix. So what is the order of this matrix? We have to consider. So the second matrix is going to be of order 2 by 2, 2 rows and 2 columns. So number of columns in the first matrix is equal to number of rows in the second matrix. So we can multiply both the matrices. So the resultant is going to have order 1 by 2. That is, the resultant is going to have 1 row and 2 columns. So this is the first thing we have to note during the product. So 1, 0, minus 2, 0, and we must write this one in the matrix form. This is a null matrix. What is the order of this null matrix? The order of the null matrix is 1 by 2. So it is going to have only 1 row and 2 column. Because it is a null matrix, all the entries are going to be equal to 0. Now, how we are going to multiply? For matrix multiplication, we have to follow 7 rule. Okay, the row element should be multiplied with the column elements. So I am going to multiply. So first row multiplied with first column. So how many elements we have in this row? We are having 2 elements, x and 1. How many elements we have in this first column? 2 elements again, 1 and minus 2. So how to multiply? First element should be multiplied with the first element, second element should be multiplied with the second element. So start multiplying. So x multiplied with 1 plus second element, 1 is multiplied with minus 2. So it is 1 multiplied with minus 2. So we completed first row with the first column. We move on to next element. It is going to be first row, second column. So we have to multiply first row with the second column. So the second column elements are going to be obviously 0. So when you multiply x into 0, it is going to be 0. Again 1 into 0, it is going to be 0, which is equal to 0, 0. So we simplify this expression. X into 1 is x. 1 into minus 2. 1 into minus 2 is going to be minus 2. So it is x minus 2. Here we add 0 added with the 0 will be 0 again. So this is 0, 0. Now we have two matrices and they are said to be equal now because both are having same order. So the corresponding element must be same. So we equate the corresponding element. So first row first column element is equated with first row first column element. So what is the answer we will be getting? We get x minus 2 is equal to 0. How to get the value for x now? We are having minus 2 here. What is the additive inverse of minus 2? Plus 2. So we add plus 2 on both sides. So plus 2 minus 2 cancel. So the final answer for x is equal to 2. So here we found the solution for x. Okay, here we have the concept of multiplication of two matrices as well as equality of matrices. So we have to be very thorough with when we can multiply two matrices. Now consider this problem. Again we are having two matrices, okay, and we are supposed to find the value for x. We are supposed to find the value for x. Okay, so we start. We have two matrices in product 2, 3, 5, 7. What is the order of this matrix? Order of this matrix is going to be 2 by 2 because it is going to have 2 rows and 2 columns. Second matrix 1 minus 3 minus 2 4. Again it is going to be 2 by 2. So number of columns in the first matrix is equal to number of rows in the second matrix. So we can find the product and the resultant matrix also order is given 2 by 2. So we are having. So this answer is correct. So minus 4, 6, minus 9, x. And we are going to concentrate only to find the value for x. Okay. Now we can opt for two methods. One method is we can find the product of all the elements and by which we can find the value for x, or the second method is directly we can find the value for x. First we will try to find the entire product, then we try to find the shortcut. Okay, we find the product of the matrix. How to find the product? We have to multiply row element with the column element. So this is the rule we are going to follow. Row element should be multiplied with the column elements. So start multiplying. First element is multiplied with the first element. So 2 into 1 plus 3 into minus 2. 3 into minus 2. First element is multiplied with the first element. Next, first row, second column. So first row is multiplied with the second column element. So 2 into minus 3. So 2 multiplied with minus 3 plus 3 into 4. 3 multiplied with 4. Okay. So we got the first row first column element and first row second column element we got it. Next we are going to find the value for the second row first column element. How to find? For second row first column element we have to multiply second row of the first matrix. Second row of the first matrix is multiplied with first column of the second matrix. So what you will get in that case? 5 into 1. First element multiplied with the first element plus second element is multiplied with the second element. So 7 is multiplied with minus 2. Next we multiply second row second column. So what is the answer we will get? For which the answer will be 5 into minus 3. First element is multiplied with the first element. The order we have to maintain properly. Plus, after multiplying the first element, we move on to second element. 7 into 4. 7 into 4, which is equal to minus 4, 6 minus 9 x. So we simplify this expression now. 2 ones are 2. 3 into minus 2 is minus 6. Here 2 into minus 3 is minus 6. 3 into 4 is 12. Here 5 minus 7 into 2, 14. Here 5 into minus 3 is minus 15. Plus 7 into 4 is 28. 7 4s are 28, which is equal to minus 4, 6 minus 9 x. Okay. Now we simplify the left hand side. When you simplify the left hand side, the answer is going to be minus 4, minus 6 plus 12 will be plus 6, 5 minus 14 minus 9, minus 15 plus 28. So both are going to have different sign. Okay. So we subtract the smaller one from the bigger one and put the bigger number symbol. So it is plus 13, which is equal to minus 4, 6 minus 9 x. Is it clear? Now these two matrices are equal, so corresponding element must be same. So we are having minus 4, 6, 6 minus 9 minus 9. Now tell me what is the value for x. So second row second column element should be equal to second row second column element of the right hand side matrix. So what do you answer? What is your answer? X is equal to 13. So this is the process of finding the solution in elaborate way. By finding all the elements of the product, then we come to the equality of matrices, then we compare. Okay. Instead, we can use a simple method which we have studied in the previous session itself. So 2, 3, 5, 7, 1 minus 3 minus 2, 4 is equal to minus 4, 6 minus 9 x. Here we are going to find the product of two matrix. The answer is also given to us already. It is also a 2 by 2 matrix. Nothing wrong in it. But we are supposed to find the value for x. Now what is the position of x? X is present in second row, second column. It is a very short method. Instead of finding all the values, we can straight away find the particular value for x, because we are going to find the solution for only one variable. We are going to find the value for x alone. No other variable is going to be there. Okay. So if you are very strong in matrix multiplication, we can find the answer directly. The second row second column element is obtained by multiplying second row of first matrix and second column of second matrix. Now what is the second row of first matrix? The second row of first matrix is going to be 5, 7. So 5, 7. What is the second column of the second matrix? Minus 3, 4. And if you multiply this one, it is going to be equal to your x. Okay. And we are going to consider only the value. Okay. It is not going to be represented in the matrix. We are going to take only the value. So this is 5, 7. This is minus 3, 4. Multiply. 5 into minus 3 is minus 15. Plus 7 into 4 is 28, which is equal to x. So your x value will be equal to plus 28 minus 15, which is nothing but 13. So we can get the answer very comfortably. So this is another way of finding the value for x directly We can find the value for x direct. We move on to next question. Now read the question. If A is equal to alpha, beta, gamma minus alpha and A square is equal to I, your A square value is going to be equal to I, then find the value of alpha square plus beta gamma. What is the value for alpha square plus beta gamma? Okay. We try to find the value for this expression, this particular expression, A square, and equate it to I. And A matrix is of order 2 by 2. And again we are going to multiply with A. Okay. A square is nothing but A into A. We have to multiply A with A. That is the meaning. We are not supposed to square each element. Okay. That is the basic mistake what the student will make. When you are supposed to find A square, they will try to square all the element in the matrix. It is a very wrong procedure. What is x square? It is x into x. What is 5 square? 5 into 5. In the same way, A square is nothing but A into A. So we have to multiply matrix A with itself. We have to multiply. So A is a matrix of order 2 by 2 and B is also a matrix. A is again multiplied with the same matrix. Okay. So the row and the column. Okay. Number of columns in the first matrix is equal to number of rows in the second matrix are equal. So we are going to get resultant matrix is 2 by 2. So your I is going to be of order 2 by 2. So we start. A matrix is alpha, beta, gamma minus alpha again. It is multiplied with alpha, beta, gamma minus alpha, which is equal to I matrix. I matrix is unit matrix, which is nothing but 1 0 0 1. Because the resultant matrix is going to be of order 2 by 2. So we have to consider only the identity matrix of order 2 by 2. Is it clear? Now we start multiplying. How to multiply? Usual method. Row element must be multiplied with the column elements. So the row elements, that is the elements which are present in the row should be multiplied with the elements present in the column. But the corresponding element, first element should be multiplied with the first element, second element should be multiplied with the second element. This process we have to follow. So we multiply. So this is going to be the first row, first column element. So multiply first row of the first matrix with first column of the second matrix. Is it clear? So multiply alpha into alpha, alpha square plus beta into gamma, which is nothing but beta gamma. Next, alpha beta minus beta alpha. Then gamma alpha, second row, first column. Second row multiplied with the first column. Gamma multiplied with alpha. Gamma alpha. Again, second element multiplied with the second element. So minus alpha gamma. Then again beta gamma plus alpha square, which is equal to 1 0 0 1. This is the answer. Now this is a matrix of order 2 by 2. Again this is a matrix of order 2 by 2. We can equate the corresponding element. So compare. And one more step we can do. If you want, it is alpha square plus beta gamma. This is 0 and this also 0, because both are going to have same magnitude but opposite sign. So cancel each other. So alpha square plus beta gamma, which is equal to 1 0 0 1. Now we equate the corresponding elements. The first row first column element is equated to first row first column element of the right hand side matrix. So what is the answer you are going to get? We get the required answer. Alpha square plus beta gamma is equal to 1. This is the required answer. So we found out the value for alpha square plus beta gamma. Okay. We move on to next question. Okay, here we are having two matrices A and B. We are supposed to calculate the product AB and B. So we are checking whether AB is possible to find the solution. To find the solution, whether AB is possible or not. Okay, A is a matrix of order 2 by 2 and B is also a matrix of order 2 by 2. So the number of columns in the first matrix is equal to number of rows in the second matrix. So AB is possible and the AB is going to be of order 2 by 2. The resultant matrix is also of order 2 by 2. Okay, we start. A is equal to 1, 1, 1, 1. B is equal to 1 minus 1 minus 1. We find AB. AB. It is 1, 1, 1, 1. 1 minus 1 minus 1, 1. We find the product. How to find the product? As usual, the row elements should be multiplied with the column elements. So we are having two elements in the row. It should be multiplied with these particular two elements in the column. So we start. We are going to find the first row, first column element. So 1 is multiplied with the 1 plus 1 is multiplied with the minus 1. 1 multiplied with the minus 1. Again, 1 is multiplied with the minus 1. 1 is multiplied with the 1. So I multiplied the first row element with the first column as well as second column. So first row multiplication is over. Next we move on to second row. Again the same process, the row element will be multiplied with the column element. So we start multiplying. First element multiplied with the first element. So 1 is multiplied with the 1. Again 1 is multiplied with minus 1. Second element multiplied with the second element. 1 is multiplied with the minus 1. Next 1 is multiplied with the minus 1. 1 multiplied with the minus 1 plus 1 is multiplied with the 1. So we are getting the answer 1 ones are 1. 1 into minus 1 is minus 1. Again minus 1 plus 1. Again minus 1 plus 1. Minus 1 plus 1. Now we simplify, we get 1 minus 1 minus 1 plus 1, again 1 minus 1 minus 1 plus 1. So we get the answer as 0 0 0 0, which is nothing but a null matrix. Although we are having a non-zero matrix, A is a non-zero matrix and B is also a non-zero matrix. Here we are having a typical solution where the product turns out to be 0. In real number it is not possible, okay. In real numbers, if the product of two numbers is equal to 0, it is necessary that any one of the numbers should be 0. If the product of two numbers, two real number turns out to be 0, in that case any one of the number must be 0. But in matrix we are having a situation where A is not a non-zero matrix, B is also a non-zero matrix. We are finding the product, but the product turns out to be a null matrix, okay, zero matrix. Next we move on to finding BA. BA, we are going to find the solution. BA is equal to, we are going to have 1 minus 1 minus 1 1 multiplied with 1 1 1 1 is equal to. So first row is multiplied with the first column. So 1 into minus 1, 1 multiplied with 1 plus minus 1 is multiplied with 1. So minus 1 is multiplied with 1. So I multiplied first row element with the first column. I move on to first row second column. So first element will be multiplied with the first element. So 1 is multiplied with 1 plus second element minus 1 is multiplied with the second element. So minus 1 multiplied with 1. So first row second column over. Next second row first column. So minus 1 multiplied with 1 plus second element multiplied with the second element. We are not supposed to stop with multiplying just a single element. So all the elements in the row should be multiplied with the corresponding position of the elements in the column. Next minus 1 multiplied with the 1. 1 is multiplied with 1. So we simplify again. This is 1 minus 1, 1 minus 1, minus 1 plus 1, minus 1 plus 1, which is equal to again 0, 0, 0, 0, which is equal to 0. So here we are getting AB is equal to BA. This is going to be the exceptional cases. Usually matrix multiplication is not commutative. In few cases, if AB is possible, sometimes BA multiplication itself not possible. We cannot find the product at all. Okay, we may have a situation like that. But in this particular case, okay, we are having the product AB and BA are equal and both are equal to the null matrix. Both are going to be equal to null matrix. Now we are going to use the concept of equality of matrices. Also we are going to use the product of two matrices. What is given? A is a matrix given to us. B is going to be a scalar matrix. Okay, diagonal matrix, not a scalar matrix. B is going to be a diagonal matrix because this is going to be the diagonal element. Okay, apart from this diagonal element, all the elements are going to be equal to 0. But AB is equal to BA. The product is going to be equal. In that case, we are supposed to prove B is a scalar matrix. When B becomes a scalar matrix, when the diagonal elements are all same. If you are able to prove that A equal to B, then the problem is solved. Okay. If the diagonal elements are all going to be equal, then the diagonal matrix will be said as scalar matrix. So we must know the definition of a scalar matrix. Then only we can solve the problem. So we start. A is a matrix with 1, 2, 3, 4. B is a matrix A, 0, 0, B. And A is a matrix of order 2 by 2. Just we check the product order. B, to write the B order, we just indent one step. So we write again 2 by 2, by which we can see that the number of column in the first matrix is equal to the number of rows in the second matrix. So the resultant AB is going to be of order 2 by 2 again, 2 by 2 matrix. So first we find AB matrix. 1, 2, 3, 4 is going to be multiplied with A, 0, 0, B. Multiply. How to find the product of these two matrices? The row element should be multiplied with the column elements. So row is multiplied with the column. So first multiply first row with the first column. So what you will get? 1 into A. First element is multiplied with the first element. 1 multiplied with A. 2 multiplied with 0. So it is going to be 0 naturally. Okay. Next, first row multiplied with the second column. We are going to multiply with second column. Okay. So first element is multiplied with the first element. So 1 into 0, 0 plus 2 into B, 2B. Then we multiply second row with the first column. Second row is multiplied with first column. So what you will get in that case? 3 into A, 3A plus 4 into 0. It is going to be 0 again. Next I am going to multiply the second row with the second column. So 3 into 0, 0 plus 4 into B. It is going to be 4B. So when you simplify, you are going to get the answer as A plus 2B plus 3A 4B. So this is your first matrix AB. Next I am going to find BA. B into A. So we write B matrix first. That is A 0 0 B multiplied with 1, 2, 3, 4. So B matrix is of order 2 by 2. A matrix is also of order 2 by 2. So here again the number of columns in the first matrix is equal to number of rows in the second matrix. So the product is possible. So the resultant is also going to be 2 by 2. So very comfortable. So we start multiplying. How to multiply? First row multiplied with the first column. That is the first element. So A into 1, A plus 0 into 3, 0. Then first row, second column. First row, second column. What you will get in that case? A is multiplied with 2. That is 2A. 0 is multiplied with 4. So it will be 0. Then 0 is multiplied with 1. 0 plus 3B. 0 is multiplied with 2. That is second row is multiplied with the second column. Second row multiplied with the second column. So first element is multiplied with the first element. So 0 into 2, 0. Second element with multiplied with the second element. That is 4B. So when you simplify, it is going to be equal to A, 2A, 3B, then 4B. This is your second matrix. Now what is given to us in the question? It is given AB is equal to BA. Given AB is equal to BA. So what will imply? This implies A, 2B, 3A, 4B is equal to A, 2A, 3B, 4B. Okay. Already you can see that left hand side matrix and right hand side matrix are equal. They are given. Okay. So first element A, here the first element is also A. And you can very well see second row, second column element and second row, second column element are same, 4B, 4B. Because these two matrices are equal, their corresponding elements must be same. So we can see that this first row, second column of the left hand side matrix should be equal to first row, second column of the right hand side matrix. So in that case, what we will get? We get 2B is equal to 2A, which implies B is equal to A. We multiply by reciprocal of 2, multiplicative inverse of 2 on both sides. So by which we can cancel the 2 on both sides. So B is equal to A. So what happens to your B matrix now? Your B matrix is going to be equal to A, 0, 0. B is nothing but A. So A. Because it is already going to be a diagonal matrix in which the diagonal elements are same. Therefore, B is a scalar matrix. B is a scalar matrix. Now read the question. Write the following as a single matrix. Write the following as a single matrix. Okay. So the question is, we are having a matrix. The matrix is going to be 3, 2, 5, 7, minus 4, 0. And here it is 2, 2, 2, minus 1, 3, 5. Minus of 7, minus 8, 5, 9. We have to simplify this into a single matrix. First, we will try to find the product. We will check whether the product is possible or not. What is order of the first matrix? Order of the first matrix is 2 rows and 3 columns. The second matrix order is going to be, how many rows this is going to have? First row, second row, third row. So 3 rows and 2 columns. So the product is possible. The number of columns in the first matrix is equal to number of rows in the second matrix. So the resultant matrix is going to be 2 by 2. So the resultant is going to be 2 by 2. Here also we are going to have 2 by 2. So we can do subtraction also. Subtraction is also possible. So we can convert this one into single matrix. That is our conclusion, first thing. Now I am going to start multiplying. How to multiply the two matrices now? Usual method. The first row will be multiplied with the first column. So we start multiplying. So first row elements are multiplied with the first column elements. 3 into 2, 6, plus second element multiplied with the second element. So 2 is multiplied with the 2. 2 2s are 4. Next, third element multiplied with the third element. 5 3s are 15 plus 15. So all these 3 elements correspond to single element. Next we move on to first row, second column. first row, second column. So we move on to the next element. 3 into 2, 6. 2 into minus 1. 2 into minus 1 will be minus 2. 2 into minus 1 is going to be minus 2. So this is 6 minus 2. Next plus 5 into 5. Third element multiplied with third element. 5 5s are 25. So I completed multiplying first row with all the columns in the second matrix. Next I move on to the next row. I have second row. So I start multiplying the second row with the first column. First element is multiplied with the first element. Here first element is 7. Here first element is 2. So 7 2s are 14. Next, second element is multiplied with the second element. We have to put a plus symbol over here, but we are having minus 4. So minus 4 is multiplied with the 2. I get minus 8. Third element multiplied with the third element. 0 into 3. It will be equal to 0. 0 multiplied with any value is going to be 0 again. Next we move on to second row with the second column. Second row with second column. So 7 into 2, 14. Here second element is multiplied with second element having minus symbol here. Here also the second element is going to have minus symbol. So minus 4 is multiplied with the minus 1. So it turns out to be plus 4. Next third element multiplied with the third element. So 0 into 5 it is 0. Minus 7 minus 8 5 9. We simplify now. Here all the elements are going to have same symbol, correct? So we add it. 6 plus 4 10, 10 plus 15 25. Here 6 minus 2 plus 25. We add 25 and 6. 25 plus 6 31. 31 minus 2. 31 minus 2. Value is going to be 29. Next we are having only two terms. 14 minus 8. 14 minus 8, different symbol we subtract. Subtract 8 from 14, the answer is going to be 6. Here all are going to have same sign. 14 plus 4 plus 0. So it is going to be 18. Here I am going to make a small adjustment here. Okay. So what I am going to do? I convert this minus to plus. So plus of, I change this one to negative matrix of 7 minus 8 5 9. So it will be minus 7 minus 8 plus 8. Here we are having 5. So we multiply minus inside. So it is minus 5. This plus 9 will be rewritten as minus 9. How to find the negative matrix of a given matrix? Multiply all the elements with minus symbol. Okay. Now this also 2 by 2. This is also 2 by 2. We can add. How to add? Corresponding element will be added. So it is 25 minus 7. 29 plus 8, 6 plus of minus 5. So it is 6 minus 5, 18 plus of minus 9. So it is going to be 18 minus 9, which is equal to 25 minus 7 is going to be, the elements are going to have different symbols. So we subtract the smaller one from the bigger one. So 7 is subtracted from 25. So it is going to be 18. Same symbol, add, it is going to be 37. 6 minus 5, different symbol, subtract. So it is going to be plus 1. 18 minus 9, different symbol. So subtract. 18 minus 9 is going to be 9. So this is the answer. And we transform the product and the difference into a single matrix. So this is the answer. Now we are going to see another typical question of finding the value for x and y. We are going to find the value for x and y using the equality of matrices after finding the product. Okay. Consider the question. Here we are having x, y, 3y, x. Okay. What is the order of this matrix? Tell me. X, y, 3y x multiplied with 1, 2 is equal to, right side it is going to be a column matrix. Your second matrix is also a column matrix. This is also a column matrix. We first check whether the product is possible. It is possible because it is given equal to symbol. Okay. So the product is possible. And what will be the resultant matrix? The resultant matrix is going to be of order 2 by 1. It is going to have 2 rows and 1 column because it is given already. But it is our process to find whether the product is possible or not. So first matrix is of order 2 by 2. Second matrix, it is a column matrix. Again, it is going to have order 2 by 1, only 1 column. So the number of columns in the first matrix is equal to number of rows in the second matrix. So they are equal. So we can find the product on the left hand side, and the resultant matrix is going to be of order 2 by 1. So we start multiplying by usual method. How to multiply? 7 shape. First row multiplied with the first column, because we are going to have only 1 column. Okay. So what is the answer? X on multiplying with 1, x into 1 plus y is multiplied with 2, y into 2. So first row multiplied with the first column, over. There is no other column to multiply. So we move on to next row. Next row, second row multiplied with the first column. So 2y multiplied with 1 plus x is multiplied with 2, and it is given to be equal to 3 and 5. So we simplify this expression. X plus 2y equal to 3 and 2y plus 2x. So we find the product. So first row is multiplied with the first column. So x into 1, it is x plus y into 2, 2y. So we don't have any other column to multiply for first row. So it is only 1 row, 1 column. Next we multiply the second row with the first column. So it is 3y into 1, it is 3y plus x into 2, 2x is equal to 3 and 5. Here also we are having 2 row 1 column. Here also we are going to have 2 row 1 column. The matrices are equal. So their corresponding elements are going to be equal. So we equate the corresponding elements. So first we equate the first row first column element with the first row first column element. So what is the answer we are going to get? X plus 2y equal to 3. Then we are going to compare second row first column compared with the second row first column. So it is going to be 2x plus 3y equal to 5. So this is taken as the first equation and this is taken as the second equation. We try to follow the method of elimination. Okay. Here the coefficient of x is going to be 1. So it is very comfortable to make the coefficient of x to be equal to 2. So we multiply first equation with 2. So what you will get in that case? 2x plus 2 2s are 4. 4y is equal to 2 3s are 6. Second equation I am not going to multiply with anything. I written as such. It is going to be 2x plus 3y equal to 5. So By elimination method, we are going to solve, because 2x and 2x are going to have same sign. We do subtraction. So subtract, minus, minus, minus. In that process, x term getting cancelled, we get 4y minus 3y. So it is y. 6 minus 5, it is going to be equal to 1. So the value of y is going to be equal to 1. So I got the value for 1. I got the value for y. With the help of y, I am going to find the value for x. Substitute in the equation. X plus 2y equal to 3. So x plus 2 into 1 equal to 3. So x plus 2 is equal to 3. I want to eliminate 2 now. So I add additive inverse of 2. 3 minus 2. So x value is also equal to 1. So we got the solution for x and y in this case. So the value of x is equal to 1 and y also equal to 1. So we got the solution for x and y. So in this session, we learned how to multiply two matrices, and after multiplication, how to equate two matrices to find the solution for the unknowns expressed in the given expressions. And also in a particular case, we found the product AB and BA are same, okay, and they are turned out to be equal to a null matrix. Okay, thank you students.